Everything in this world has a time to live. My snow thrower has a time to live. My car has a time to live. What determines the time to live of those devices? Well, how well you maintain them. Oil changes, tune-ups, all of that comes into play. Our packets also have a time to live. And we can see that time to live displayed in the packet header. Depending on the device, depending on the operating system, depending on the implementation, will determine what the time to live is of a packet. For example, you might see Windows devices using a time to live of 180. You might see a Unix device using a time to live of 64. Cisco router is using a time to live of 255. So the number is going to be different depending on the vendor and the implementation. But what is the overall purpose of the time to live? Well, that's going to be the same for all of them. It's how long this packet lives on the network if it hasn't reached its destination yet. So if we examine our topology, we have a PC that is sending a packet. If the packet has a time to live of 128, what's going to occur? Well, every time a router touches that packet, it decrements the time to live. So now the time to live is 127. Now it's 126. Now it's 125. Now it's 124. Oh, reached the destination. So everything's great. But what happens if the packet was sent, for example, from this device with a value of 128? So now it's 127, 126, 125, 124, 123, 122, 121. What's happening here? We have a routing loop. So the time to live is a feature that was placed in to make sure that we can eliminate a routing loop. Now, the elimination doesn't happen right away, as you can see, because this packet will keep going around and around and around for how long? It's going to keep going around and around until the time to live expires. And then once that time to live expires, then the packet is going to be dropped. And once the packet is dropped, the router that drops the packet has a responsibility. And that responsibility is to send an ICMP message back to the host that originally sent that packet. And that ICMP message is known as an ICMP time exceeded message. So for example, in this case, let's say our PC right here sends out a packet with a time to live of 3. It arrives at this router here. The router routes it. What's the time to live now? The time to live is now 2. This router receives it and forwards it. What's the time to live now? 1. The router receives it, forwards it, and what's the time to live now? 0. Wait a second. Will a router forward a packet with a time to live of 0? No. So at this point in time, this packet is considered dead. It's done. So now this router has to send an ICMP time exceeded message back to the host. So time to live is simply router hops. That's what it is. Router hops.